Hello, welcome. Today we're going to be looking at geometric progression, GP, geometric progression. In arithmetic progression, we say that the difference between successive numbers can be gotten by addition or subtraction, isn't it? I'll call it common difference. Now in geometric progression, the difference between successive numbers are gotten from multiples, is that clear? Or factors, is that clear? And it is known as what? Common ratio. It is known as what? Now, geometric progression is a sequence in which any two consecutive terms differs by a constant multiple or what? Factor. The constant multiple or factor is called the common ratio, while the first time is denoted by the letter what? A. Can you see this geometric progression? What is the common ratio? 3. Why is 3 the common ratio? Because 6 times 3, 18. 18 times 3, 54. 54 times 3, 162. You understand? The difference is gotten by multiplication or division. You understand? Unlike the other one that is gotten by addition or what? Subtraction. Now, this is another sequence, geometric progression. What is the common ratio? 1 over 2. 1 over 1 over 2, which is the same as 3 over 2. 16 times 3 over 2. 24. 24 times 3 over 2, 36. 36 times 3 over 2, 54. 54 times 3 over 2, 81. So this first sequence, the first time A is what? 6, and the common ratio is what? 3. The second sequence, the first time is what? A is 16, and the common ratio is what? 1 over 2, or you call it 3 over 2. Now, very, very important, you need to know the end term of a GP. You need to know the formula for the what? End term of a GP. And it's simply given by Tn is equal to the first term A times R, which is the common ratio, to power what? N minus 1. Is that clear? And the sum of the terms, let's say some of the first 3 terms will be S3, isn't it? So if you have Sn and some of the terms, it's going to be A into brackets R to power N minus 1 all over R minus 1. Is that clear? You can also write this formula in this form. A into power 1 minus R to power N all over 1 minus R. You use this value when the common ratio is greater than 1. When the common ratio R greater than 1, use this formula. But when 1 is greater than the common ratio, you use this formula. Then one last formula that you need is what? The sum to infinity. When n is tending to infinity, what will be the sum? It is A all over 1 minus what? R. So with that, we can take this example. The 8th term of a GP is 640. If the first term is 5, find the common ratio and the 10th term. Who can help? Here is my clipboard cleaner. Good. Who can help me solve this? I'm going to erase from here. Isn't it? So once I erase from here, I'm going to solve for this. So what are the given? 8th term. So I'm going to have 8 term. How do you represent the 8th term? Is what? T8, isn't it? Is equal to 8 to power 8 times R to power M minus 1. Equal to what? It's already given as what? 640. Is that? So what is A? 5, because the first term is 5. What is R? We don't know. What is N? 8 minus 1 equal to what? 640. This is going to be 5 R to power what? 7 equal to what? 640. And this is going to be R to power 7 is equal to 640 over 5. Multiply, what will you get? 128. And this is going to be R equal to 7th root of 128. What would that give you? 2. So the common ratio is what? 2. The common ratio is what? 2. But we are told to find also the 10th term. So if the common ratio is 2, we know that 10th term is simply T10 and it's equal to 8 to power R n minus 1, isn't it? So it's going to be A is what? 5. R is what? 2. N is what? 10 minus 1. And it's going to be 5, 2 bracket, 10 minus 1, 9. It's going to be 5 times 2 to power 9. 512. So 512. So 5 times 512 is what? 2560. And that becomes your what? That becomes your what? Answer, the 10th term. Did you see this procedure that I went through? Did you see the procedure? Huh? First of all, is it correct? Huh? Press the calculators very well. If you like this video, click on the subscribe button, like and share our videos. See you in the next class. Thank you. Bless you.